Today we're going to discuss with you about the images we meet in the studies related to optics. Light rays build images. You've seen so many images ever in your lifetime. But do you know how they're built up? In this video, I'm gonna explain to you clearly about the logical background of the images, clarifying what they really are. Come and enjoy art science, which touches the artistic places of science and makes people informed. I'd like to begin our discussion, considering the images created by a plane mirror. But before that, I think it's necessary to refer into a very important incident light occupies in, and it helps the mirrors to create images. That is reflection. If light returns back to the same medium, after having traveled through it and hit on a barrier, that incident can be called reflection. There are two basic principles of reflection. The first one is that the ray of incidence, the ray of reflection, and the perpendicular drawn to the tangent, created at the point of incidence and the barrier, must certainly be on the same plane. The second one is that the angle of incidence the angle between the ray of incidence and the perpendicular, and the angle of reflection the angle between the ray of reflection and the perpendicular, are similar in size. Then let's find out how a plane mirror creates the image of an object. In a ray diagram, we normally consider a couple of rays released from a single point on the object, and find the place, actually the point, where those two rays cross each other after being reflected. We name that place the image of the particular object. An object is considered to be made of an infinite number of particles. Having added the images of all other particles in related places, a complete image gets created. Always in ray diagrams, we use only one couple of rays for the convenience. But actually, a couple of rays represent a light beam made of millions of light rays. This expresses the idea that only two rays are sufficient to us to introduce the place of the image and predict its attributes. But we can't touch the above image. We can only see it. So it should be something that doesn't really exist, but seems to be existing. What is the reason for this? Let's find out. The reason is written on how we do see an object, and what we do observe as an object. The light rays which travel in the free space collide on objects and are reflected, because objects are solid, physical things actually exist in the world. In this way, any place where light rays are released from, generating or reflecting or anyhow, is recognized as an object by our mind. If two rays meet together in somewhere and there's no barrier, from that very place it will release those two rays. So we think to be an object there at the particular point also. Pay your attention to this ray diagram. The object is here. A couple of rays are released from the object. They collide on the mirror and reflect, then come into our eyes and show us the image. Here, the two reflected rays will never meet together, because they are diverging. But we can recognize them to be released from a single point which is merely virtual. We can go backward along the two reflected rays as this, and find that point. This world has been created according to a unique pattern. We can also call it a program. This program has inserted a lot of principles into our brain in order to show the world to all human beings alike. One of them is that the motion of light is linear. That's why we look at those two rays diverging from a single point and think it's the truth. Although they've been reflected, we don't think so. Instinctively we're not able to see so. Then we recognize the object out to be there, not in front of the mirror. It is the so-called image. This is the simple mechanism of forming an image. We are cheated by an illusion and think it is the truth. Therefore the images always exist in our mind, but not in the real world. Then let's inquire about the formation of images by lenses. If you want to come to know further details about lenses, please watch our video on refraction and lenses. Here also, the previous mechanism continues. At point A, the reflected two rays cross each other, and then they are released from A. Since we recognize a place where a couple of rays are released from as an object, we think the object should be at A, and it is called the image of the particular object. Including the ray, comes along the principal axis of the lens, the beam comes to the eye of the observer is wider than the beam released from the object. This tells that the image is larger than the object. As well, the solar light beam has expanded after being refracted by the lens, so the image is less in shine than the object. Can you realize a difference between the images formed by the plane mirror and this lens? In this ray diagram, at point A light rays actually meet together. But in this, point A is merely a virtual one, which doesn't really exist. Light rays don't go there. Because of this reason, this image can be taken onto a screen, but this image can't. Then you might be thinking what I meant by taking the image onto a screen. If we place a screen here as this, we can observe the image on it. What happens here is that the light beam collides on the screen and reflects to this side, and this observer catches it by his eye. Here, he's able to see a maximized, upside-down image. So we call this image as a real image. But the image created by the plane mirror is a virtual image. Not only of real objects, but we can have images of virtual objects also. Observe this ray diagram. These two rays could have been reflected by a spherical mirror, or refracted by a lens. If there wasn't this lens, the couple of rays would form this as an image. But this lens has prevented the execution, and moved the image to another place, also minimizing it. So for this lens, the image has become a virtual object, as it doesn't release real light rays. Here also, our eye is cheated, thinking that light rays come from point B and the object is there. So we can say that the image is there. This is also a real image, so that it can be taken onto a screen. I think you may have gained a good understanding about formation of images through this video. If you want to learn more about lenses, and come to know the real reason for refraction, please watch our video on refraction and lenses.
Thank you for watching this video. If you gained something from this video, don't miss to like it and share it. Subscribe my YouTube channel for more video like this. Click the bell icon for getting a notification about my channel. See you again.